All right, let's come back in this video and talk a little bit more about increasing investment. So we had this idea that increasing investment leads to increase of capital, which leads to increase of production. And that's basically true, but it's not quite as simple as economists first thought. So back in the 1940s and we could possibly say 1940s and 1950s, economists thought that this process worked like this. And so you're going to see this a lot in this class. Economists like to show ideas using pictures. So over here on the x-axis, we have capital per labor, capital per worker. So this is how much machine structures, equipment is there per worker. And up on the y-axis, we have the output per worker. So how much is each worker producing? So originally, they sort of thought it worked like this. They sort of thought it was a straight line. Okay, so this is our production function. And they thought it was basically a straight line. So let's suppose you had this much capital to start with, then you're going to get this much production. And then let's suppose you did an increase of this capital. Well, then your production is going to go up a certain amount. And then if you do the same size increase, well, the production would go up by the same amount again. Okay. So if you see this, well, you say, well, that's easy. Growth policy looks really easy. Growth policy should just be increase the capital as high as possible. And then your economy can basically just take off like a rocket. It's going to just go, well, I guess it's not exactly like a rocket, but it can just go and go and go and go, and there's no limit to any of this process. So that's how economists initially thought of this, probably in the 1940s and maybe to the 1950s. And then they said, well, wait a second, probably this is not exactly how it works. Actually, it's possible that at first the capital will be really useful, but then eventually, as you already have lots and lots of capital, this process is going to slow down. So you can kind of imagine if you are trying to do some work with little or no equipment, it probably wouldn't be very effective. It would take tons and tons of effort, and you probably wouldn't get very far. But as you add more and more equipment to what you're doing, then you probably have the basics of what you need to do the job. And then adding more to this and more and more and more after that likely won't make you very much more productive. One of the things is you might not have enough hands or people to even operate all the equipment that you might have at some point. So it turns out that if you keep everything else constant, then and you only increase the capital, that it doesn't appear to work this way. Okay, so something. The more sophisticated version of it is called the Sowell model that we're going to talk. It's coming now. Said, well, it probably works more like this. So it probably works more like at first the capital is really effective, but once you get a lot of it, then it becomes less effective. Okay, so that would be like, for example, if we are, let's start from here. Let's start from where we started down here. This is where you start with a very low level of capital, and you're going to have a low level of output. And then we increase capital quite a bit. And we get a big increase in our output per worker. So the workers are much more productive. Now they have a good amount of things to work with. And then we do that again. And we still get a pretty good increase in output. We'll call this K2 over L and Y2 over L. But it's slowing down. So the first increase of output was much bigger than the second one, even though the increase in capital was the same. And then finally, let's do the same thing again. So we're going up here, same size increase. And then the last one, we find a very small increase in output. So this is the more realistic situation. So when your economy, we can label these points. No, actually, for now, we don't need to label. But when your economy starts from a very low level of capital, as you increase the capital, you get more output. But this extra increase in output per adding capital slows down. So let's write this down, and then we kind of discuss the implications. So this is called the diminishing returns to capital. So we add more and more capital to the same everything else, right? So as our capital per worker gets higher, adding more capital is less returns or less increase in production. Okay, so that's our idea. So they realize, well, Actually, this isn't the magic formula. Now, it's important if you are starting from the beginning point of K0 and Y0, then yes, increasing capital will make a big difference. So for very low income countries with very low levels of capital usage, definitely increasing capital is going to make a big difference. But in the long run, as far as countries get to a level of capital that's quite per worker that's quite high, they're going to have to do something else. And so this model is quite useful because it points us towards something else. So what is that something else? So we draw our same thing, capital per worker. So remember, we've been drawing, well, like A to B, right? A to B would be done by investment. So we're going to increase our capital per worker. And we could increase our output by doing this. So the question is, well, once we get to B, just adding more capital and more capital of the same type isn't going to really make much difference. So what should we do? And the answer is, well, we should try to get more out of our same stuff. And so this is called technology, right? So here we get an improvement in technology. So if we improve our technology, we improve our way of doing things, our way of organizing things, our way of communicating, then we can get more out of the same resources. All right, so that allows us to move here to C. So A to C is from increase of technology. And so this model finally tells us that yes, increasing capital is very important, especially in the early stages of growth, but eventually increasing technology is the secret to long-run growth. It can also tell us one other thing. This model can also tell us one other thing. And that other thing that it can tell us is about the catch-up prediction. I think in your textbook, often this is known as convergence. Okay, so the catch-up, and that's that if we have, say, country A and country B, right? So we would expect, well, if they invest at the same rate, at the same levels, we expect country A to grow faster, right? And then it can sort of catch up. So for example, if they were both investing at this rate, well then A would grow a lot and B would barely grow at all. Again, remember the growth is seen in the vertical, right? The growth is seen here. So in that case, country A is growing really fast and country B is growing really slow. So this model doesn't tell us that this is guaranteed to happen, and we can look in the real world to know that this is not guaranteed to happen, but it's possible. So it's not guaranteed that this will happen, but it's possible. An example of this from the 1960s to the 1990s would be South Korea and the US. So South Korea during this period of time grew at about roughly 6% per year, and the US grew at about 2% per year. At the beginning of this period, the US economy, the GDP per capita was way, way, way bigger than South Korea. And by the end of this period, and even up to now, the difference is much, much, much smaller, right? So it appears South Korea has caught up. Now, if we look around the world, there's lots of countries that haven't caught up. There's also countries that have actually even fallen further behind. But there is a group of countries, most of which are found in East or Southeast Asia, that they have done this catch-up phenomenon, and we can kind of illustrate it with this simple graph here. In the next videos, let's move on to other ways to increase capital and other ways to increase the other factors.